Hello students, welcome to grade 10th chemistry class. In the previous session of atomic structure, that is the part 1, you have learnt about the subatomic particles present in an atom, that is the protons, neutrons and electrons, and how they were invented. You have also learnt about various atomic models that had led to know the presence of these subatomic particles. But the question is that it was observed like atom of one element is different from the atoms of other element, we need to understand the nature of light, the colored flames and its characteristics. So this can be done when you observe the spectrum. It can be visible spectrum or continuous electromagnetic spectrum. So to understand better, let's get started. So here, to know about the nature of light and the color of different lights, different flames can be understood very well basing on spectrum, that is electromagnetic spectrum. Now, what is this electromagnetic spectrum or what is the spectrum? So here you can see in the slide that electromagnetic spectrum, and in this different rays are given like gamma rays, X-rays, ultraviolet rays, which is UV rays, visible, infrared rays, microwave, radio waves, etc. You must have heard some of the rays or some of the waves in your regular, like UV rays you must have heard, visible spectrum you must have heard, that is Vibgyor, rainbow colors. You must have heard few of them. Now, what are these, where they are present and what is the range of them can be known by going ahead. Now, let's see what is electromagnetic spectrum. Electromagnetic spectrum. Before learning or knowing about this electromagnetic spectrum, let's see first what is a spectrum. You must have heard about a rainbow. Yes, which you see after a rain, which is very beautiful. And this rainbow contains how many colors? Yes, 7 different colors. They are violet, indigo, blue, green, yellow, orange and red. In short, which we call it as Vibgyor. So here, this Vibgyor is a continuous spectrum because violet and then immediately indigo, following blue, followed by green, yellow, orange and red. So it is a continuous spectrum, and since it is visible for us, we can call it as visible spectrum. So when you say after this, as it is continuous, it can be named as a continuous visible spectrum. In the same way, imagine another instance where you are hearing some sound waves, and these sound waves are produced because of vibration. Why I should take you to the vibration or sound waves is, here when the sound waves are produced or when they are propagating, they move because of vibrations. And how do they move is, they move back and forth. So these waves, when they are moving, sound is produced. So sound can be produced because of vibration, and these vibrated bodies produces sound. So here electromagnetic waves are also produced when an electric charge vibrates. How the sound waves are produced? Because of movement or vibration. The same way, electromagnetic waves can also be produced when electric charge vibrates. So here, when an vibrating electric charge creates a change in the electric field, this changing electric field will create a changing magnetic field. Just when you imagine the situation of a sound waves are produced because of vibration of sound particles. In the same way, electromagnetic waves are produced because of vibration or movement of electric charge. And this moving electric charge or vibrating electric charge produces electromagnetic waves, because when an electric wave is moving, it produces the magnetic field also to change, and a magnetic field is created. So this together, electric and magnetic field together, creates electromagnetic field. And this electromagnetic field contains electric waves and magnetic waves which moves perpendicular to each other. So here, coming back to this, you have observed that electromagnetic waves are produced, and these electromagnetic waves are produced because of movement of electric charge, which in turn produces magnetic field. And together these two fields are called as electromagnetic field. So here, when electromagnetic waves are moving, they carry charge along with them. So these waves which are moving continuously is called as an electromagnetic spectrum. It can be for example, like how you are telling visible spectrum, the same way electromagnetic spectrum. So what is this electromagnetic spectrum? Electromagnetic spectrum is a complete spectrum of all forms of light. So here I stress on the phrase all forms of light, which means that it is not only visible light, as you see now, visible light and also electromagnetic waves of different ranges. So electromagnetic spectrum means it is a complete spectrum which is continuous and contains all forms of light which may be visible or may not be visible. Okay, so what is an electromagnetic spectrum? Electromagnetic spectrum is a complete spectrum of all forms of light. Now, what does they contain? What are all the forms of light? It contains radio waves, cell phone waves, microwaves, radar waves, infrared waves, visible light waves, UV waves, that is ultraviolet waves, X-ray waves, gamma waves. So these are the different types of waves. So here you can see that radio waves, microwaves, infrared waves, ultraviolet, gamma rays, and in between radio and microwaves, mobile waves, then microwaves, radar waves, infrared waves, then visible spectrum, ultraviolet spectrum, X-rays, gamma rays. So these are the different types of light forms, and together is a continuous spectrum. Now, note down these points. So here, when you have studied that spectrum is a continuous form of light waves, the properties of electromagnetic waves include speed, frequency, and wavelength of the light waves. So when you know about the spectrum is a combination of different types of waves. It is different types of light waves, and each light wave has a different frequency and wavelength. So here you must note down the point that the properties of the electromagnetic waves includes speed, frequency and wavelength, which means that the property of these electromagnetic waves depend upon frequency, wavelength, which in turn depends upon the speed. So speed, frequency and wavelength are related in the formula as S. Speed can be denoted as S since we are speaking about speed of the light. It is represented by the letter C also. So C is equal to, or S is equal to frequency into lambda, where F stands for frequency. The frequency of the waves is represented by the letter nu, not nu, it is NUE, nu, and lambda is wavelength. So speed of the light is equal to frequency into wavelength. All the light waves travel at a speed of 3 into 10 to the power of 8 meters per second in vacuum. So using the above formula, that is velocity speed is equal to frequency into wavelength. The speed of the light waves was observed to be 3 into 10 to the power of 8 meters per second, which means that C can be calculated. That is, the velocity can be calculated using the formula F into lambda. So here when we are defining speed is equal to frequency into lambda, which means that frequency and lambda are also related and they are reciprocal of the other. But have you got a doubt what is the frequency and what is wavelength? Let's see what they are. In the next slide, I'm going to explain what it is. Continuation of these points, relationship between wavelength and frequency. All parts of the electromagnetic spectrum travel at the same speed. I have told you that electromagnetic spectrum is a continuous spectrum. And if you observe in the electromagnetic spectrum, you have seen that radio waves, gamma rays, cosmic rays, all these are present. And the speed of them is same. All parts of the electromagnetic spectrum. Here all parts means it can be gamma rays, X-rays, radio waves, microwaves, ultraviolet rays, anything. The speed of each part of the spectrum is same. Therefore, wavelength and frequency have an indirect relationship. So, which means that when all these waves are traveling at the same speed means the quantities which are helping to find out the speed, that is wavelength and frequency, have indirect relationship between them, which means that as one characteristic increases, the other decreases. Since speed has to be same, it should be same for all the parts of the electromagnetic spectrum. So here, when it should remain the same, the relation between these two quantities becomes more crucial. So if one quantity increases, the other quantity decreases to balance the value or to balance the product of frequency and wavelength. When one quantity increases, the other quantity decreases. In other words, what we can say is, as wavelength increases, frequency decreases. So here, as wavelength increases, frequency decreases. But as wavelength increases, what about its frequency? Frequency will increase. They are indirectly proportional to each other. So electromagnetic wave characteristics are that the spectrum which has short wavelength have high frequency. The spectrum which has short wavelength have high frequency, and which has long wavelength has low frequency. So remember that wavelength and frequency are indirectly proportional. They are not directly proportional. They are inversely proportional. Like when wavelength is short, frequency is more. If wavelength is more, frequency is low. Electromagnetic waves and energy. So here in the previous point you have learnt about the relation between wavelength and frequency, which are inversely proportional to each other. So here when wavelength and frequency are inversely proportional and the wave is propagating, wave is moving, this wave carries energy. So you need to know about the relationship with energy also. So here the relation that was observed is high frequency waves have high energy whose wavelength is short, and low frequency waves have low energy. Okay, remember the relation between wavelength and frequency is inversely proportional. Forget long, short and everything. Remember the relation, that is wavelength and frequency are inversely proportional. Frequency and energy are directly proportional. That is, if frequency increases, energy also increases. Now let's try to fill up this table. Before doing this, recollect the relationship between wavelength and frequency. This is inversely proportional and these two are directly proportional. Frequency and energy are directly proportional. So wavelength is long, means it is more. Then frequency is less. Energy is also less, yes. Now next one. Here it's given that frequency is high. Then wavelength is short. Then energy of this high frequency is also high. Okay, are you clear? Shall we move on to next one? So students, here in this slide you can see the complete electromagnetic spectrum. So this spectrum consists of gamma rays, X-rays, UV rays, visible rays, infrared rays, that is IR rays, microwave rays, radio waves. So these are the different types of light rays which are present in electromagnetic spectrum. And here you can observe that the wavelength of electromagnetic spectrum starting with gamma rays is 10 to the power of minus 12, X-rays is 10 to the power of minus 10, UV rays 10 to the power of minus 8, visible spectrum 10 to the power of minus 6, infrared rays 10 to the power of minus 5, microwaves 10 to the power of minus 2, radio waves 10 to the power of 0, that is 1 meter. And the wavelength of gamma rays is less than 1 meter. And here this is the wave of shortest wavelength. Moving from right to left, the wavelength is increasing. So gamma rays is at shortest wavelength and radio waves have highest wavelength. And when you observe, if wavelength is small, frequency is more and its energy is also more. So in that way, when you see here, gamma rays have shortest wavelength, so its energy is more. Since wavelength and frequency are inversely proportional, frequency is more and energy is also more. So try to practice this. Remember, just remember the different types of light waves which are involved in electromagnetic spectrum, which are present in the electromagnetic spectrum with their range of wavelength. Why we should say range is here, it slightly varies from 10 to the power of minus 12 to minus 11. And X-rays 10 to the power of minus 11 to 10 to the power of minus 10. So it is, since it is a continuous spectrum, these rays overlap on one another also, sometimes it's a continuous. And here gamma rays is shortest wave and radio wave is highest wavelength. Let's try to know about different types of light waves, starting with microwaves. Microwaves are longer than radio waves but shorter than infrared waves or visible light. The wavelength of them is from 1 into 10 to the power of minus 4 meters to 10 to the power of minus 1 meter. Microwaves are useful in the field of communication, medicine, and also for consumer use. How these microwaves are useful in medicinal field is they play an important role in the fight against cancer. The treatment given for cancer is microwave ablation. So this microwave ablation means process of removal of unwanted matter, unwanted tissues is known as ablation. So this process is commonly used for the removal of unwanted tissue masses. It can be tumor also, which are present in lung or liver or in the other parts of our body. So these microwaves are useful in cancer treatment as ablation, that is to removal unwanted tissues. And how they are useful in consumer use is that, or in the communication is, here the microwaves, they send the signals. Here you can see the tower. So in the field of communication we need two devices, transmitter and the receiver. So here both the transmitter and receiver, when these are working, the microwaves carries a signal to them from transmitter to the receiver. So Since they are of shorter wavelength, they carry longer energy. So, due to this property of microwaves, they are useful in the field of communication. Next is radio waves. These radio waves are low energy waves with long wavelengths. They include FM, AM, radar and TV waves. That is frequency modulation, amplitude modulation, radar, radio detection and ranging, and TV waves also. The wavelengths of them is 10 to the power of minus 1 meter and it is longer. So they have low frequency. And the radio waves are used in many devices such as remote control items, cell phones, wireless devices, etc. In general, in our daily routine, we are using remote controls for TV, AC, and many things. And when you play with remote cars and all, we are using remote control. So here the radio waves are useful in all these devices wherever remote control item and cell phones, wireless devices, etc. But how they are useful is in mobile phone. For example, that is cell phone, how they are used is here when we are communicating in a mobile, it's more necessary to be within the range of the base station of one's operator. It may be any operator, any service. It should be in the range of base station of one's operator and they should receive a signal of sufficient quality. This sufficient quality of radio signal is indicated on our mobiles by bars, and nowadays it's like accompanied with a sign like 4G, 3G or E, which means it is at the edge of the quality. So here, when the quality is at the edge, it is represented by E. And when it is at higher edge, like more than 3G, 4G, and now 5G is also going to be start. So each signal or the quality of the signal is displayed with the symbol like in 3G or 4G anything. So depending on the available technology in the area. Now when we make a call on the mobile, it searches for the nearest signal from the base station and then establishes a link. Then we get connected to the person whom we are calling. Then how they are used in wireless devices. The same process like the wireless devices requires a process of sending and receiving the signals and it is done through wireless network which involves two devices, that is transmitter and receiver. So here the transmitter sends the signals and they are received by the receiver. Since these radio waves are carrying energy with them, they also carry the signals with them and they are received by the receiver. So in this way, the radio waves are useful in cell phones, wireless devices and remote control. That's the reason when you use the remote control, you can see when you try to change the channel or increase the decrease the volume, when you are clicking on the button, you can see the radiation, that is change in the brightness of the light. So here it is going to change, means it is received by the receiver there. In this way, the radio waves are useful in different devices. Next is infrared waves, that is IR waves. These are invisible electromagnetic waves that are detected as heat. So IR rays are invisible and they are electromagnetic waves. These can be detected as heat. So all the heat radiating objects are possessing infrared waves. They can be detected with special devices such as night goggles. So IR waves can be detected using night goggles. That is night vision goggles which are used to take or to extract the image of certain places. So here you can see in the picture there is an animal which is called as night goggle. Why it is named as night goggle is this is a diminutive Southeast Asian primate and the vision of it is equal to world's equivalent night vision goggles. The night vision goggles which are used to take the image of certain things, the vision of it is equal to its, that is the capacity of night vision goggles is equal to the vision of this animal. And next, infrared rays are used in heat lamps. In the lamps also it is used. Then it has higher energy than microwaves but lower than the visible light. Next is visible light. That is the light that is visible to us is visible light. So here in this slide you can see the rainbow, which means rainbow in general we must have seen many number of times. So rainbow is visible spectrum, and this visible spectrum contains different colors of violet, indigo, blue, green, yellow, orange and red. So the portion of the electromagnetic spectrum that human eyes can detect is visible light. What is a visible light? The portion of the electromagnetic spectrum that human eyes can detect is known as visible light. And this visible light possesses VIBGYOR, that is violet, indigo, blue, green, yellow, orange and red. Though it's written here, I read in reverse, which I have started from shortest wavelength to highest wavelength, which means that violet is having shortest wavelength and red is having highest wavelength. So when red is having highest wavelength, its frequency is less. So here the next question is, which color has the lowest frequency? Red has lowest frequency and violet has highest frequency. Remember that when we say VIBGYOR, the 7 colors are violet, indigo, blue, green, yellow, orange and red. And the wavelength of them is from smaller to bigger. Violet is at shortest wavelength and red is at longest wavelength. So here is a spectrum. So visible light, this is the visible light, and the other side of the visible light or the visible spectrum contains UV, X-rays and gamma rays, which you are going to learn now. And infrared rays, radio waves are on the left side of it. The next is UV rays, that is ultraviolet rays. Ultraviolet waves are higher energy than light waves. They can cause skin cancer and blindness in humans. So you must have heard many number of times like UV rays are more powerful and very dangerous also. Why they are dangerous is they can cause skin cancer and also even blindness also. But luckily we are not in or not receiving the ultraviolet rays directly. So our ozone layer is protecting us from reaching the Earth's surface. And UV rays are used in tanning beds and sterilizing equipment. So here, though it is dangerous in one way, it is useful in tanning beds and sterilizing equipment. What is this tanning bed? A tanning bed. So here you can see a tanning bed. In generally, it is called as a tanning bed or sunbed. This is a machine which is used to produce an artificial tan. Why it is called as tanning bed is to tan the skin. This bed is useful. So it is known as a tanning bed. And this tanning bed machine is used to produce an artificial tan. Generally, when we are under focus of UV rays, our skin gets tanned. Some people like to get their skin tanned. So to get it done, they use this tanning beds because using this machine, tanning is done quickly by initializing. How it is done is this artificial tanning bed can initialize sun's UV rays and it leads to faster melanin production than what happens under the sun. And next is about sterilizing equipment. How they are useful for sterilizing equipment and where they are used is, since they are so powerful, they are useful in sterilizing like hospitals, organizations and in public places. The UV rays are useful. But nowadays we use the other rays of the disinfectants to use or to sterilize. Next is X-rays. X-rays are higher energy waves. They are used in medicine, industry and astronomy. How they are useful is just like the medicinal field, X-rays are used to take or to find breaks or cracks in the bones. Industrial radiography uses X-rays to take pics of the products because they can show the problems that are not visible to the naked eye. Here, when X-rays are passed through a body or through an object, since they are highly energetic, they can penetrate through and they can take the picture or they can show the picture of the object or the bones where the crack or the defect is caused. So using that picture, it can be treated. X-rays can also cause cancer. They are helpful in the medicinal field, but they can cause cancer. So long exposure of X-rays can cause cancer. Last but not the least, it is gamma rays. Gamma rays are highest energy rays. They are blocked from Earth's surface by atmosphere. Gamma rays are highest energy rays and these rays are blocked from Earth's surface. How they are blocked is, in general, gamma rays can be blocked by inches of lead, concrete or steel. But luckily, our atmosphere is blocking them. Not only gamma rays, our atmosphere is blocking most of the UV rays, X-rays, gamma rays from reaching the Earth's surface. So in that way, we are protected by atmosphere from reaching the gamma rays. Now it's time to remember what you have learned in this session. The first question, what is the relationship between frequency and wavelength? Frequency nu and wavelength lambda. So recollect the formula and where they are useful and for what it is useful to know or to find the velocity of light or the speed of the light represented by the letter C is equal to nu lambda. C is equal to nu lambda, which means that frequency and wavelength are inversely proportional to each other. So how they are related? Frequency and wavelength are inversely proportional. Next question. What characteristic of gamma rays gives them the higher energy? So higher energy, gamma rays are having higher energy. So which waves will have higher energy? If the frequency is more, energy is also more. So frequency is high, so energy is also high. But what characteristic is making them high? That is, the characteristic which makes the gamma rays to be at higher energy is highest frequency, that is shortest wavelength. So shortest wavelength and high frequency is the characteristic property of the gamma rays which gives higher energy to it. Then next, what does Roy G BIV mean? What does it mean? If I read from right to left, it is VIBGYOR, means violet, indigo, blue, green, yellow, orange and red. What part of the electromagnetic spectrum does it refer to? Which part? VIBGYOR, when we say, what clicks in our mind? It is rainbow, which is visible. So it is reflecting visible spectrum. Next question. Which color is more energetic, red or yellow? Since they are from shortest to the highest, which is more energetic, yellow is more energetic since it is a shortest wavelength. The next one, which type of wave travels faster, gamma rays or radio rays? Gamma rays and radio rays, both of them travel at same speed. All the light rays travel at same speed. In that case, not only these two, all the light rays travel at same speed. The next question, why are microwaves more dangerous than radio waves? The reason is that microwaves are more dangerous than the radio waves due to its high frequency and energy. So with this, I conclude the session, and in the next class, you are going to learn about the different types of light rays, different colors of light rays, and the reason behind for it. Thank you.